This video is about angles and circles. One of the situations you'll meet is where you have a triangle formed from two radii with the ends of the radii joined together. It's an isosceles triangle because it's got two equal sides, so it's got two equal angles at the base. Going to use that to look at angles in a semicircle. A diameter is drawn in here, so that forms two semicircles, and the ends of the diameter are joined to a point in the circumference to form an angle. That's the angle in a semicircle. So it's formed from the ends of the diameter to a point in the circumference. Going to show that's a right angle. So if I say this is angle size A and this is angle size B, and then draw in a radius to form an isosceles triangle here where angle B is at the base. So if this is angle B, this is also angle B, two equal angles at the base. Similarly here, this was angle A, this is also angle A because it's an isosceles triangle with two equal angles at the base. So the angle at the circumference here is A plus B. That means it doesn't matter what A is and what B is, this will always be A plus B. If you add the three angles up in the triangle, it should make 180 degrees. Well, if you add the three angles up, we've got two A's and two B's. So 2A and 2B made 180. So halving that, 1A and 1B must have been 90. So A plus B is always 90. That means it doesn't matter what A is or what B is, this will always be 90 degrees. The angle in a semicircle is always 90 degrees. So to illustrate this, here's a angle in a semicircle. Ends of the diameter are joined to a point in the circumference. This is 90 degrees. Doesn't matter where that point is, this is always 90 degrees. So that's the angle in a semicircle. So that's the first result we were after. This is the second case. This is a line. This is a point. And the distance of this point from that black line, if we were to go along this red dotted line, that's the distance from this point to that line. This point here is some position on that black line. But if I move that position to the left here, the distance from this point to the line decreases. And then it starts increasing again. So the distance from this point to that black line varies according to where in the black line you draw the red dotted line. The least distance, the shortest distance, is this position when this red line is perpendicular to the black line. In other words, it forms a right angle. When you've got a 90 degree angle here, then that's the closest this red dot here is to that red dot. So this second red dot's some position on the line, and only when you make a right angle from this point to this point do you get the shortest distance. So that black line here now is the shortest distance from this point to that black line. It's only when that's a right angle. Any other position, that red line is the hypotenuse of a right angle triangle. So it's bigger than the black line. It's always bigger than the black line until it's right on top of it. So that's the shortest distance from this point to that black line when you make that right angle. If I draw a circle in, this black line just touches the circle at this one point. That's the point of contact. And this line from the centre of the circle to that point of contact is a radius. Basically, we've got a tangent a line that meets the circle at one point. We've got a radius drawn out to the point of contact, and it makes a right angle. So that's a tangent. There's a point of contact with the circle, one point of contact, and the radius drawn out to that point of contact is making a 90-degree angle. You can illustrate that here. So that's the situation. The blue line here is a tangent. It meets the circle at one point. You draw the radius out from the centre to that point of contact. This will always be a right angle. Doesn't matter where the point of contact is. As long as you draw the radius out to the point of contact, you make a right angle. So that's the second situation. A tangent and the radius drawn to the point of contact makes a right angle. Third situation is, if I have a circle, I could draw a diameter in and it will be a line of symmetry. Doesn't matter where I draw in the diameter, absolutely anywhere, it's a line of symmetry. However, if I put a chord in the circle, a chord is a line joining 2 points in the circumference. Only one diameter is a line of symmetry. It's the diameter which, when you draw it in, makes a right angle with the chord, and it halves the chord. So it's got to half the chord at 90 degrees. That's the only diameter which is now a line of symmetry. We say the diameter is the perpendicular bisector of the chord. So perpendicular means at 90 degrees, bisecting means halving. It halves the chord at 90 degrees. If you have a chord and there's a line that halves it at 90 degrees, that line must be a diameter. In other words, it will go through the centre. If you have a diameter, a line through the centre, and it makes a 90-degree angle with the chord, it must be halving it. Or if you have a diameter and it halves the chord, it has to be at 90 degrees to it. So there's three things: the diameter, the 90 degrees, and the halving. If two of these three things is true, then the third thing is also true. So to illustrate that, there's a situation. The blue line is a chord that joins 2 points in circumference. The red line goes through the centre, it's a diameter. The diameter halves the chord at 90 degrees. So the three things, the diameter, the 90 degrees and the halving, go together. You've got a diameter, it's at 90 degrees to the chord, it's halving it. You've got a diameter, it's halving the chord, well, it must be at 90 degrees to it. You've got some line that halves the chord at 90 degrees, that line's got to be a diameter. So it's a line through the centre. So here in summary is the three things we've got: angle in a semicircle, a right angle; tangent, the radius drawn out to the point of contact, makes a right angle; a chord, a diameter, halves it, it's got to be making a 90-degree angle. So we're going to be looking at angles for this. You'll be given circles, you'll be given lines, and you have to use these properties to figure out the missing angles. So when you look at this one, there's a tangent here, there's a radius, line from the centre, meeting the tangent at the point of contact. That angle A must be 90 degrees, it's a right angle. And then there's a triangle making 180. So you can work out A and B. A is 90, angle between a tangent and the radius drawn to the point of contact, and then the triangle made up to 180 gets to 65. Here's two radii, and the ends of the radii joined together to make a triangle. So we've got an isosceles triangle, two equal angles at the base, but the triangle is to make 180, so it must be 30 and 30. Next, we've got a radius and a tangent. So we've got a right angle between the tangent and the radius drawn to the point of contact. So that's a 90-degree angle in here, the right angle. And since this part of it's 30, this missing part here has to be 60 to make up the 90-degree angle. So it's 30 and its complement 60. So 30 and its complement 60. So we've worked out the missing angles. Here we've got two things. We've got the angle in a semicircle. So we've got, we've got that right angle. That's the angle in a semicircle. And that means that missing angle is 60. So there's 30, a right angle. 60 makes the triangle up to 180. So that's a semicircle. We've got a chord being halved by a diameter. So that requires a right angle. So that must be a 90-degree angle. And this top triangle is 30. There's 90. So this angle in here must be 60 to make that triangle up to 180. And then since this is a right angle at 90 degrees, this part of it's 60, and here must be its complement 30. 60 and 30 make 90. So the two key things were diameter, halving a chord, must be at 90 degrees, and the angle in a semicircle is 90 degrees. It wouldn't actually matter which one you worked on first. Of these 90 degrees, it doesn't matter whether you work in the top triangle and then the bottom one, or whether you start as I did with a semicircle. There's going to be a worksheet. If you click the link in the description, you can get the worksheet. It'll have angles to work out using letters A, B, C and so on. So in this one, this is a semicircle. That's the angle in a semicircle, so that's a right angle. There's a right angle triangle now, so that works at 40, 50 and 90 to make 180. Next, there's a tangent, and there's a radius out to the point of contact, so that's a right angle in there. So C is the complement of 40. In other words, it's 50, so 50 and 40 make up that 90. So the worksheet will have 4 questions. It'll have 3 circles with each question, and each circle will have 3 angles you have to work out. And it'll involve these situations with angles in a semicircle, angles between a tangent, the radius drawn out to the point of contact, and a diameter and a chord. So there's a worksheet. If you click the link in the description, you can get to the worksheet. 4 questions, 3 circles, 3 unknown angles in each circle, and it'll have the answers. And using the same link, a set of notes, it covers all the videos and angles. That was for the first video. Second video was quadrilaterals. And now we've covered circles, covering the angles part. The next video will be on the same thing as this video, these properties for these 3 situations, but right angle triangles can be constructed in each case because we've got the right angle involved, and that will bring in Pythagoras' theorem. So that's the next video. You could use trigonometry, but that's covered in separate videos. Hope you found this video useful. Thank you.